Okay, let's start the class. Okay. Today I'm going to focus on geometry. I'm not sure you still remember. The topic is about triangle in chord. Okay, now you're given three sides. Okay, given three sides of given three numbers A and B and C. The question is whether or they are formed. There are three sides of a triangle. Okay, now there are the A, B, C are the side lenses of if and only if they are satisfying following encoding. Okay. Well, sorry, internet was like a little bit unstable today. It's a big storm here. So A plus B should be greater than C. Okay, because A plus B longer than C. Clear, right? And the B plus C should be greater than A. And the C plus A should be then greater than B. Okay, so those are called triangle inequalities. Okay, so why? Because if B and A add them together is smaller than or equal to C, you're not going to make a triangle. Okay, no matter how, you cannot touch together. Okay, if the base is C, and you're not going to make a triangle, so it's obvious. Okay, that's the first thing. Second thing is we needed to know the Pythagorean theory. Okay, so if the triangle has three sides A and B, C, okay, and this is called the angle. Okay, the theta angle is going to be 90 degrees. That means the right triangle. If and only if A squared plus B squared equals C squared, and that is called the Pythagorean theory. Okay, so in other words, if you know the relationship, this is a triangle. If that satisfies A squared plus B squared equals C squared. So those are the two important things we should know. We know the area form is a triangle. Okay. All right. So now here's a bigger project. Okay. So we yes, Alex, already you're allowed to do that. Okay. I know that you're going to require. So let's consider a triangle. This is an isosceles triangle. Okay. Okay. So we know that this is an A, and here's A. This is this triangle. Okay, this is an isosceles triangle. I know the parameter is going to be 18. Okay, and the A and the B are integers. That's important. Okay? So my question is, what is the smallest area of such triangle you can have? Okay, you cannot randomly check, right? So that means so parameter is parameter is 2A plus B, right? Right, 2A plus B equals 18, and A, B are integers. And what is the smallest possible area? So how do you solve this problem, this big problem, okay? When you see a problem like that, you have to make sure how many possible triangles you can have, okay? First of all, you notice that, yeah, we look at the triangle inequalities, okay? They form a triangle. Those have three inequalities: A plus A greater than B. Okay, A plus B greater than A, B plus A greater than A. You know, then you find out this is trivial. This is always trivial, right? A plus B is of course greater than AB. So the only inequality you needed to be careful is about this. Okay, 2a greater than b, then you can get a triangle. Otherwise, it's not going to be a triangle. Okay. So look at this identity. Okay. 18 equals 2a plus b. And 2a is greater than b, right? So b plus b. So that means my b here is less, cannot be larger than 9. Otherwise, they have some troubles. And on the other hand, 18 equals 2a plus b. I'm going to replace b. b is less than 2a, so 2a plus 2a, which is 4a. Then you divide both sides by 4, okay? Then 18 over 4 should be less than 8. So 18 over 4, and this is a 4 point something, right? Yeah. 4.5. So a is greater than, but a, this, here indicates b is 1 to the positive value is going to be 1 to 8. The z implies a is going to be 5, 6, 7, right? But it cannot be too large. Okay. So let's look at all the possible triangles you can have. Okay, this is analysis, right? So from above formula, b equals 18 minus 2a, which is a. And from here, clearly a cannot be too large. A cannot be equal to 9, right? So a started from 5 because originally a must be from 5. So when a equals 5, what is a b? B is going to be 8, okay? That's one triangle you can get, okay? So you can have 5, 5, 8, right? Then when a equals 6, 2 is 6. Then you get equality triangle, right? When a equals 7, 9 minus 7 is 2. 2 times 2 is 4. And this is also a triangle. It's getting very narrow, okay? 7, 7, 4, okay? Then when a equals 8, a cannot be 9. And the b equals 9 minus 8 is 1, 1 is 2, right? Even slim. Right. So you have to calculate. Okay, you have to calculate. Okay. So by the Pythagorean theory, if this is h here, this is h, right? H. Let's calculate the h, the height of each thing. H is going to be square root of 5 square minus 4 square, and this is going to be 3 clear, integer. And this h will be square root of 6 square minus 3 square, okay? And what is the number? 36 minus 36 minus 9, right? So it's going to be, I think it's 3 square of 3, okay? Yeah, 27, square root of 27. Okay, and then here it's going to be 7 square minus 2 square, 49 minus 4 square, 45, right? Okay, we don't know how large of square root of 45. You can estimate. Okay, and this h is going to be 8 square minus 1 square because half of the base is 1. And that's 63. And that's square of 3 times square of 7. So you have the height, then you know how to calculate the area. Each of them you get half of the base times the height, right? It's 12, okay? And this area is going to be half of 6 times the height, okay? So that would be 9 square of 3. And here, this is going to be half of the 4 times square of 45. It's 2 square 45. and this will be area is going to be half of 2 times the height square of 7. So it's a 3 square of 7. So now you can compare those numbers and you can tell which one is large. Okay? And if you put inside radical, maybe it's much easier to check. This is going to be 144 square root, right? This is going to be let's see what it, yeah, 81 times 3 squared 243, and this will be 45 times 4 and square 180, right? And this will be 7 times 9 is a square 63. And from clearly, the equilateral triangle gives you the largest possible area. Okay, and this will be the smallest possible area. Okay, largest, smallest area. Right? So let's review this problem. By the triangle inequality, you can figure out all the possible triangles, so whose parameter is going to be 18. Okay? Right? Then for each of them, you can calculate the height, and then you calculate the area. My next, yeah, we know the Pythagorean theorem, we know the triangle inequality, right? My next problem will be as follows. Let's review the squares, okay? Given a square, right? If you have no a's, right? And then this is d, right? By the Pythagorean theory, d squared equals a squared plus a squared equals 2a squared, right? So if you take radical, then it's square root 2 times a. So that's a relationship. D is going to be square root 2 times a. Okay. Now, here's a question, okay? If the length of the diagonal of a square is 6 feet, okay? What is the area? Well, you are given, not given the side length. Area, you know that. Area is going to be a times a squared. But you're not given a directly. What you are given? You are given the length of the diagonal, d, right? But there is a relationship between a and d. Because I know that d squared equals 2a squared. So all I need is a squared, which is d squared over 2. Right? So that's why area is going to be half of d squared. What is d squared? D squared is d is 6 feet. So okay, it's going to be 18. Okay, I'm going to ask you to do the following problem. Okay, I have a rectangle. This is a rectangle. The length of the diagonal, d, is going to be 15. The width is going to be 5. What is the area? Okay, please do this problem. Okay, those who are listening, please take a pencil out and try to work out. Hello? You doing that? Don't fall asleep. I just find the area, right? I haven't got any answers from you guys. I have to call your name. Right? Andy, are you there? James, you should give me the answer. Oh, Toby have answered. Toby says 50 times square root of 2. James says 70. Now, come on. Got 2 different answers now. Any different answers? What do you say? 70.1? Don't use the decimal point.
I got 50 times square root of 2.
So 50 times square root of 2 maybe right. Don't estimate, okay? Square root of 2 is square root of 2. All right, so how do you do that? You have to find the length, right? According to the Pythagorean theory, Pythagorean theorem, right? Length is going to be the d squared minus w squared, right? Yeah, width. So it's going to be 15 squared minus 5 squared. The question is, how do you simplify? So we will simplify the following. 15 squared is 3 times 5, right? 15, right? So you have a 5 squared, you can take it out. Right? So you get 5, and the square root of 9 minus 1 is 8, but square root of 8 is going to be 2 times square root of 2. It's 10 square root of 2. So that is the length. Once you get the length, then you can get the area. Area is going to be length times W. 10 square root of 2 times W is 5, so 50 square root of 2. Great job. Okay. So, Louis, did you estimate? But don't do that, okay? You have to get the exact value. Don't need to replace square root of 2 by 1.14. Okay, I need the equality, not an estimate. So square root of 2 is perfect number, in the answer. Okay. So those are called two-step problems, and we're not always use we have two-step means you're not given the data you need directly in the formula. You have to find out by yourself. All right. So here's a square with side length of 2 units is constructed on the side on a right triangle was the hypotenuse of length of 2 square 2. So this is a right triangle and 2 square 5. Right, and this is going to be square. So that will be 2 and 2. It's a square. Okay. So my question is, what is total area? Area of the figure. Okay, can you see that? So please look up this. Tobias says 8. Any different answers? Vincia Lee, are you working on the problem? Now, what is missing when you're trying to find the area? Okay, this is a triangle, right? So we have A and the B, right? So in order to find the area as a total area, you just need to find the area as a triangle. But clearly, A is going to be 2. Once you get an A, you can get a B. B is going to be square root of 2 square 5 square minus 2 square. Right? By the Pythagorean theory, it's like a triangle. That's how do you figure?
I switched them around.
All right, so it's going to be, 20 minus 4 and square of 16, that's a 4. Okay, so you find the A and the B, then the total area, the area of the triangle, and times B, and plus the area of the square, 4 plus 4, which is 8. Great. Good job. All right, so our next problem is the length of a rectangle is increased by 20%, and the width the same time is decreased by 20%. Okay. My question is by what percent is the area changed? Right. So the width decreasing and the length increase. So this is a rectangle. So it's getting longer, okay? Length is increased, the width decreased. Any idea about the percentage problem? What does it mean? You know, decrease by. Tobias says the area is decreasing or increasing. Well, I guess 3 different answers. Come on. By what percent? By, okay, I will say, by what percent is the area changing? And you have to tell me whether it's increasing or decreasing. Jasper?
I think it decreased by 4%.
You said decrease by 4%. Vincia said decrease. Tobias, everybody said decreasing. Okay, so let's try, okay? So this is the width, this length. The width is increased by 20%. 20% is original one plus 0.2 L, which is 1.2 L, okay? The width is going to be decreased. So original width minus 0.2 width, okay, which is going to be 0.8 W of the original one, right? Decreased by 20%. So the decreasing part is 0.2 times W. So the area is changed to A prime is going to be L prime W prime, right? L is 1.2 L, W is 0.8 L, 8 W, okay? So let's do the multiplication. 1.2 times 0.8, okay? 1.2 times 0.8 is going to be 0.96 LW, right? LW is the original area. So the area A prime is a new area. It's going to be 0.68. So what does that mean? Smaller, okay? Smaller. You can also write it A minus 0.04A. So this is a decreasing part. Okay, 1 minus 0.04 is going to be 0.96. So decreased by 4%. Okay. Okay. Right, here's another one. It's about rectangle. Our rectangle EFGH is inscribed in rectangle ABC. Okay, it goes like that. It's a rectangle, okay? A, B, C, D, E, F, G, H. Okay, E, F, G, H. Okay, so those are the rectangle E, F, G, H is inscribed in a rectangle A, B, C, D, okay? So what data we are getting kept? So the angle, this is 30 degree. Okay. And this is a 12. Right. And the GH is going to be 2 square 3. What is the area ABC? All right, try out this to see if you're able to get it. Now, we do need to know that we have to do some preparation, the special triangle, okay? Special right triangle, otherwise you're not able to solve the problem. Special right triangle. That means when you have triangle, and this is a 30 degree, and here's C, and here's A and B, right? So A over C should be equal to 1/2. B over C should be equal to square 3 over 2. Right. So are you able to use that to get the information you need? All right, please do that. Yeah, let's draw the picture again.
Can I see the problem?
Yeah, can you see the problem? Yeah, let me redraw the picture. Oh, it's bad drawing. All right, let me redraw it. Draw the triangle first. Yeah. Then that's okay. Here's 30 degree. It's 12, right? And this will be 2 square root 2, 3. Okay. Yeah, that's all the information you have here. So you have to figure it out. My hint here, you have to figure out this side, X. This side is Y, right? And this side is Z. This side is W. If you can find X, Y, Z, W, and then you can get the area of the rectangle. Okay, can you do that step by step? Using a special triangle, right? So this is 30 degree. Then this will be 60 degree, right? If this is 60 degree, I think this is 30 degree, right? Here, this is 60 degree. How about this one? I think this is 30 degree. That's 60 degree. Okay, so clearly X is going to be 6. Half of X, 12. Right. Now, how about the Y? Y is going to be square root 3 over 2 times 2 square root 3. Okay. Okay, after you cancel 2, you get 3. Z is again is 2 square root 3 times 1/2 it's square root 3. All right, so how about W? And this side is also 12. So W is going to be 12 square root 3 over 2. So it's 6 square root 3. So you get all of them. Okay. Then the area A is going to be x plus y times W plus Z. X is going to be 6, y is 3, W 6 square root 3, and the Z square root 3. Nine times 7, 9. Yeah, 6 3 times square root 3. Yeah, just use a special right triangle. Let me repeat again. It's a special right triangle. If it's one, why this is true? You know, why this is true? It's a special right triangle. Okay, do you remember? Oops. Yeah, it's a special. Yeah, can you prove that the special right triangle? The 3 sides are equal. The 3 sides are related by the above formula. Okay. So let's look at this again. I have a triangle, right? That's a 30 degree, that's a 60 degree. Right? I duplicate. So this is a A, that's a B, that's a C. But then I duplicate, I guess 60 degree, right? That's a 30 degree. And clearly B becomes a height of this equilateral triangle. A should be half of C because this side is a C. That's what this force is. A is going to be half of C. Or A over C equals 1/2.
But C is already the diagonal.
No, I'm trying to find the relationship between the 3 sides. Okay, so I want to see how A is related to C in this special right triangle. But the special right triangle, if I duplicate, clone it, then I put together, I get the equilateral triangle. So that force is A equals half of C, or A over C equals 1/2. All right, now how about the B? B is by the Pythagorean theory, B is a C square minus A square, because I already know the A square is going to be half of C. So after I simplify it, it's going to be 3C squared over 4. So it's a square root 3 over 2 times A times C, times C, times C. Okay, i.e. B over C is going to be square root 3 over 2. That's a ratio. Okay. All right, so let's look at the next one. So here's ACB. The triangle ABC is an isosceles triangle. So AC equals BC, in other words, right? So AC equals BC. X is a point on the side, and so that CX is going to be 6. Okay, and the XB is going to be 12. So Y is on the B side. Okay. Such that XY is perpendicular to AB. What is the ratio of the area of the, find the ratio of the triangle area of BXY and the area of triangle ABC. So the triangle is uniquely determined by the data we are given here. Okay, so this side is going to be 18, right? 18, 12. Now this is a picture. Right, so are you able to figure out the triangle, the small triangle? Basically find the area of the small triangle, because the area of the larger triangle is, we already know that, base times height divided by 2. Okay, please work out this. Are you done? Okay. Look at, right? It's tough, right? Right. So we're going to find the ratio. Now, I think here we needed to know the similarity of triangle. Okay. So the similarity of triangle, actually this triangle, if you turn this upside down, okay, so you will get B, Y, X, right? And then this, the smaller triangle and the larger triangle is similar. Okay, think about that. So this side will be 12. We don't know the other side, okay? Yeah, we don't know by, we don't know yx. Okay. But the triangle bxy is similar to the triangle BSC. Okay, so you needed to, you can figure it out. Another problem, you don't need to use similarities. Then what you can tell is this is a 45 degree, right? That's a 45 degrees because isosceles, right? Triangle, right? If you don't use a similarity, probably don't need that because we haven't learned that. Okay, that's in the advanced math class. So can you figure out this side? If this is A, that's A, right? Okay, right. So here, this is also 45 degree, then the other one must be 45 degree. This isosceles right triangle. Why it's 45 degrees? The same B. I did not even change it, right? Yeah. So a square plus a square equals 12 square. So in other words, a square equals 12 square divided by 2. Okay. So it's going to be, I think it's 72. Okay. A square is 72. You don't need this is a square. Okay. Now, so that gives you the area of the triangle BXY, but the area of triangle ABC is already given. So the ratio, okay, is going to be the area of the, right, half of a square, right, because it's there. And then the other one is half of 18 square, because I already know the side. Okay, so it's going to be a square 72. 18 squares, and you just simplify it. Okay. Yeah. Yeah. 8 times 9. This will be 18 is 2 times 9, so 4 and the 9 square. So I cancel 9 and I cancel 2 to 9. Oops, like who says oops? Alex. Okay. So that's 2 to 9. So the idea is very simple. You just figured out the smaller triangle is also isosceles right triangle. But if you know the hypotenuse of the triangle, then you should be able to figure out the area. Okay. But you can also use similarity, but then we're not going to start similarity triangle here. You can solve the problem. Okay. Maybe we have to study similarities. Okay, let's look at the next problem. Okay. 2 rectangles are similar. You see? Are similar. What do you mean? 2 rectangles are similar. Similar means the ratio of the width to the length is the same. Okay. So this is maybe one is larger, other one is smaller. Okay, but they're similar. Okay. It cannot be like one is a square, other one is a non-square rectangle. Okay. Okay. The smaller rectangle has length 9 units, okay, and the width 5 units. Okay. The larger one The large triangle has what's going on here? Come on. Please go, yeah. Its length 4x minus 3 units and width 2x plus 2 units. Okay. What is a parameter? What is x? Let's just find x. What is the value of x? Okay. So this side is 9, this side is 5, and the length is 4x minus 3, 2x plus 2. Now, similar really means the ratio should be the same. I mean, the ratio, the width to the length should be the same, okay? So in other words, similarity implies 5/9 should be equal to 2x plus 2 over 4x minus 3. Okay. The width over the length should be the same. Okay, because those two triangles are similar. These two rectangles are similar. Okay. So from here, then you solve for x. So 4x plus 4x minus 3. You get a linear equation equals 9, 2x plus 2. Right? So multiply this up. 20x minus 15, 18 plus 18. Right? Then 18, 2x equals 18 plus 15. 33. So x is going to be 33 over 2. Okay? So let me talk about a few problems about, no, we still have another problem, equilaterals, quadrilaterals A, B, C, D, okay, are similar, okay? So two quadrilaterals are similar. If the area of the quadrilateral is, no, I'm not going to talk about this. This is about similarity. All right, so I'm going to look at the cylinder. I hope you remember the cylinder, okay? A cylinder. This is a circular cylinder, okay? The diameter of the height of a closed cylinder are equal, okay? We know that the diameter equals the height. If the volume of the cylinder is 128 pi cubic units equals 128 pi, what is the surface area? This is a units cube, right? So let's have a quick review about the cylinder, right? How do you find the surface area cylinder? Okay, so where's my file? Yeah. See, this is a radius, right? This is the height. The surface area The surface area includes the top and the bottom part, okay? Surface area. It's a closed cylinder, okay? So how do you calculate surface area? Area pi r squared, right? Top one plus the bottom one plus the area of the side surface. It's a I didn't touch this. So it's going to be 2 pi r, right? Is if we open the cylinder, then you get a rectangle times height. Okay, we are given the information. We are given the following information. 2r equals h. 2r means the diameter. Okay. We also given the volume is given, right? The volume. What does the volume mean? Volume is going to be pi r squared times h, right? Which is going to 128 pi. All right. So roughly speaking, we are given, get rid of the pi, we are given the following information, 2r equals h, r squared h equals 128. We are going to find area, which is, 2 pi r squared plus 2 pi r h. Okay? All right, are you able to figure out the value? I think you can solve for R first. Okay, from the top, R squared times H is 2R equals 128. So R cubed is going to be 128 divided by 2, which was 64. Okay, which is 64. 64, and that implies the radius is going to be 4, right? You figured out. Then H is going to be 128. H is going to be 2R, right? So it's going to be 2R, that's going to be 8. So once you get R and H, then you can get an area. Area is 2 pi, R squared, 4 squared, 2 pi, R is 4, H is 8. Okay? So then simplified, okay? Simplified 16 times 2, right? It's a 32 pi, and then 64 pi, add them together, 96 pi, okay? So 96 pi is going to be the answer, okay? So let's quickly look at this problem. It's several steps. You have to list the given information clearly and draw the picture. And then step by step, you can determine the radius, you can determine the height based on the information you're given. And then use that to find the area. This is called the two-step problem. You want to find the area, surface area, you know the formula, but you're not given the radius, you're given the height directly. You're given indirect. So you have to find out them first. Okay, just like you are given the circumference of the circle, what is the area? Then you have to figure out the radius. Then you find the area. Similar right now. Okay, so we stop here. Where's my file?